Deep in the constellation of Cygnus, some 580 light-years from Earth, lies a mysterious world known as Kepler 186f. Discovered in 2014 by NASA's Kepler Space Telescope, this exoplanet sent ripples of excitement through the scientific community. Why? Because Kepler 186f holds the distinction of being the first Earth-sized planet found in the habitable zone of its star, the sweet spot where liquid water might exist on a planet's surface. This region, often called the Goldilocks zone, is neither too hot nor too cold, making it just right for the possibility of life. In a universe filled with extremes, Kepler 186f stands out as a quiet, tantalizing hint of a world that might resemble our own. Orbiting a red dwarf star called Kepler 186, this planet is bathed in the faint, reddish glow of a star much smaller and cooler than our Sun. Red dwarfs are the most common stars in our galaxy, making them prime targets in the search for habitable worlds. Kepler 186f completes a full orbit every 130 days, a year far shorter than Earth's, but perfectly suited to its dim star. Despite being closer to its star than Earth is to the Sun, the planet receives just the right amount of light and heat to potentially support liquid water. With a radius only 1.1 times that of Earth, Kepler 186f is strikingly similar in size to our planet, suggesting it could have a rocky surface perhaps dotted with mountains, valleys, or even shimmering lakes. What makes Kepler 186f so extraordinary is its place in the habitable zone. Unlike many other planets found in this region, which are often massive gas giants, Kepler 186f's Earth-like size hints at a solid surface where water could pool, and perhaps life could thrive. Scientists estimate its mass might be slightly greater than Earth's, but we don't yet know if it has an atmosphere, oceans, or the right chemistry for life. Its discovery reshaped our understanding of the cosmos, showing that small, rocky planets like ours might be scattered across the galaxy, orbiting the faint glow of red dwarfs. The Kepler Space Telescope spotted this world using the transit method, detecting tiny dips in the star's brightness as the planet passed in front of it. This technique revealed not just Kepler 186f, but 4 other planets in the same system. However, those siblings orbit much closer to the star, making them scorching hot and inhospitable. Kepler 186f, as the outermost planet, sits comfortably in the habitable zone, a cosmic oasis in a crowded system. Its discovery was a milestone, proving that Earth-sized planets could exist in the right conditions far beyond our solar system. Studying Kepler 186f is no easy task. At 580 light-years away, it's far too distant for our current telescopes to capture direct images of its surface or analyze its atmosphere in detail. Does it have oceans? Could its atmosphere support life, or has it been stripped away by the radiation of its red dwarf star? Red dwarfs, while long-lived, can unleash powerful flares that might erode a planet's atmosphere over time. Whether Kepler 186f has withstood these cosmic challenges remains a mystery, but that uncertainty only adds to its allure. Future missions like the James Webb Space Telescope might one day peer into its atmosphere, searching for signs of water vapor, oxygen, or even hints of life. Close your eyes and imagine standing on the surface of Kepler 186f. The sky glows with the soft, crimson light of its red dwarf star, casting an otherworldly hue over the landscape. Strange mountains rise in the distance, and perhaps the gentle lapping of waves echoes from an unseen shore. Is there life here? Maybe simple microbes hide in hidden pools, or perhaps the planet is a silent, rocky world, waiting for explorers from a distant star. Whatever its secrets, Kepler 186f is a beacon in humanity's quest to understand our place in the universe. As you drift toward sleep, let Kepler 186f carry you into the cosmos. It spins quietly around its star, a distant cousin to Earth, whispering of possibilities in the vast starlit night. Its existence reminds us that the universe is full of wonders, waiting to be explored. Perhaps one day we'll unlock its mysteries, but for now, it's a gentle reminder of how beautiful and boundless the galaxy can be. Kepler 16b. Picture a planet far away, where the sky is painted with the light of not one, but two suns, setting and rising in a cosmic dance. This is Kepler 16b, a remarkable exoplanet that feels like it stepped out of a science fiction dream. Discovered in 2011 by NASA's Kepler Space Telescope, Kepler 16b lies about 200 light-years away in the constellation Cygnus. It's a world that orbits not a single star, but a binary star system, a pair of stars locked in a gravitational embrace. This makes Kepler 16b the first confirmed circumbinary planet, a world that spins around two suns, evoking scenes from Star Wars Tatooine. Kepler 16b orbits a pair of stars, Kepler 16a, a star about 2/3 the mass of our Sun, and Kepler 16b, a smaller red dwarf, only 1/5 the Sun's mass. These two stars orbit each other every 41 days, creating a dynamic and ever-changing sky for the planet. Kepler 16b itself takes 229 days to complete one orbit around this stellar duo, following a path that weaves around both stars' combined center of gravity. With a size comparable to Saturn, about 8.5 times Earth's diameter, and a mass roughly 1/3 that of Jupiter, Kepler 16b is likely a gas giant, possibly with a dense core shrouded in thick layers of gas. Its surface temperature is a chilly -73 to 100 C, too cold for liquid water, suggesting it's not a home for life as we know it. What makes Kepler 16b so extraordinary is its orbit around two stars. This circumbinary orbit is a delicate balance, as the planet must navigate the gravitational pull of two moving stars without being torn apart or flung into space. Scientists once thought such orbits would be too unstable, but Kepler 16b proves otherwise, showing that planets can thrive in the complex dynamics of binary systems. Its discovery was a triumph of the transit method, where the Kepler telescope detected tiny dips in starlight as the planet passed in front of both stars. Remarkably, the stars also eclipse each other, creating a symphony of light variations that helped confirm the planet's existence. The planet's environment is as alien as it is mesmerizing. Imagine standing on a hypothetical moon of Kepler 16b, gazing up at a sky where two suns rise and set. One star, brighter and yellowish, dominates the day, while the smaller red dwarf adds a crimson glow to the twilight. Shadows would shift and dance as the stars move across the sky, sometimes aligning, sometimes drifting apart. The planet itself, a massive ball of gas, might shimmer with faint rings or turbulent clouds, its surface a mystery hidden beneath layers of hydrogen and helium. While too cold for life, its very existence challenges our understanding of where planets can form and survive. Studying Kepler 16b is a window into the diversity of the cosmos. Its stable orbit in a binary system suggests that such worlds might be common in our galaxy, where half of all stars come in pairs. However, its distance of 200 light-years makes direct observation difficult. We don't know if it has moons, an atmosphere rich with exotic compounds, or even faint rings like Saturn's. Future telescopes like the James Webb Space Telescope might one day reveal more about its composition, but for now, Kepler 16b remains a distant enigma, a testament to the universe's ability to surprise us. As you close your eyes, imagine Kepler 16b gliding through its orbit, bathed in the light of its twin suns. The stars waltz in the sky, casting their glow over a silent, gaseous giant. This world reminds us that the universe is full of wonders, where planets can dance around not one, but two stars, in a cosmic ballet that stretches across light years. Let its strange beauty carry you into dreams, a gentle whisper of the galaxy's endless possibilities. Deep in the constellation of Cygnus, some 4,200 light-years from Earth, lies a world that defies imagination. Known as Kepler 70b, this exoplanet holds the record for one of the fastest orbits ever discovered. Found in 2011 by NASA's Kepler Space Telescope, it circles its star in a mere 5.76 hours, a breathtaking sprint through space. This scorching, Earth-sized planet orbits a subdwarf B star, a remnant of a once massive star that has shed its outer layers. Kepler 70b's extreme proximity to its star and its blistering environment make it one of the most extraordinary worlds we've ever encountered. Kepler 70b orbits its host star, Kepler 70, at a distance of just 0.006 astronomical units, roughly 10 times closer than Mercury is to our Sun. Its parent star is a hot subdwarf, a compact stellar core left behind after a star has exhausted most of its fuel. With a surface temperature estimated at 7,000 C, Kepler 70b is a fiery world, likely covered in molten rock or glowing with intense heat. Its size is comparable to Earth's, with a radius about 0.76 times that of our planet, but its composition remains uncertain. Scientists believe it could be the remnant core of a gas giant, stripped of its atmosphere by the star's intense radiation, leaving behind a dense, rocky, or metallic body. The planet's discovery was a scientific marvel. Kepler 70b was detected not through the usual transit method, where a planet dims its star's light by passing in front of it, but through reflected light. The planet's surface, scorched by its star, reflects a tiny fraction of the star's intense glow, creating subtle variations in brightness that Kepler's sensitive instruments detected. This technique revealed not only Kepler 70b, but also a companion planet, Kepler 70c, with an equally rapid 8.23-hour orbit. These planets are thought to have survived the dramatic expansion of their star during its red giant phase, a rare feat that suggests they were once much larger worlds, possibly gas giants, now reduced to their cores by stellar forces. What makes Kepler 70b so remarkable is its extreme orbit. Completing a full orbit in under 6 hours, its year is shorter than a typical workday on Earth. This rapid pace places it in a class of ultra-short period planets, where intense stellar radiation dominates. The planet's surface is likely a hellish landscape, with temperatures hot enough to melt rock or even vaporize metals. Its proximity to the star also raises questions about its survival. How has it endured such harsh conditions? Some scientists propose that Kepler 70b and its companion were once farther out, migrating inward as their star evolved, their outer layers evaporating under the subdwarf's relentless heat. Studying Kepler 70b offers a glimpse into the life cycles of stars and planets. Its host star, a subdwarf B, represents a late stage in stellar evolution, a glimpse of what our Sun might become in billions of years. The planet's existence challenges our understanding of planetary formation and survival in extreme environments. At 4,200 light-years away, direct observations of its surface or atmosphere are beyond our current technology. Future instruments, such as advanced space telescopes, might one day reveal more about its composition, perhaps confirming whether it's a rocky remnant or a metallic core. For now, Kepler 70b remains a testament to the resilience of worlds in the face of cosmic extremes. Kepler 70b stands as a fiery enigma in the vastness of space. Orbiting its star in a relentless, blazing sprint, it defies expectations of where planets can exist. Its molten surface and fleeting orbit paint a picture of a universe filled with surprises, where worlds endure conditions unimaginable to us. This tiny planet, racing around a stellar remnant, reminds us of the dynamic and ever-changing nature of the cosmos, a place where even the most extreme worlds find a way to persist. Deep in the constellation Centaurus, some 434 light-years from Earth, lies a young star system that holds a secret of cosmic proportions. At its center is J1407b, an exoplanet unlike any other, discovered through a series of remarkable observations in 2012. Using the transit method, astronomers detected a complex pattern of dimming in the star's light over several weeks in 2007, revealing the presence of a massive ring system surrounding the planet. This ring system is so vast that it eclipses the star in intricate ways, hinting at a structure far more elaborate than anything seen in our solar system. The rings of J1407b are truly awe-inspiring. With an estimated diameter of about 120 million kilometers, they are over 200 times larger than Saturn's rings. If such rings encircled a planet in our solar system, they would stretch across the sky, visible even during the day, a celestial spectacle beyond imagination. These rings are likely composed of ice and dust particles, orbiting the planet in a delicate balance, possibly shaped by the gravitational influence of unseen moons. At the core of this magnificent ring system is J1407b itself, a gas giant of immense proportions. While its exact mass remains uncertain, it is believed to be between 10 and 40 times more massive than Jupiter, placing it in the category of superjupiters. Its composition is likely similar to that of gas giants in our solar system, with a thick atmosphere of hydrogen and helium, but on a scale that dwarfs our familiar planets. The discovery of J1407b challenges our understanding of how planetary systems form and evolve. The sheer size of its ring system suggests that such structures can develop in the early stages of a star system's life, perhaps as material from the protoplanetary disk coalesces into rings and moons. The gaps within the rings may indicate the presence of exomoons, carving out spaces as they orbit the planet, much like the moons of Saturn shape its rings. J1407b stands as a testament to the diversity and wonder of the universe. Its colossal rings and massive presence remind us that the cosmos is full of surprises, where worlds can take on forms beyond our wildest dreams. As we continue to explore the stars, J1407b invites us to imagine the endless possibilities that await discovery, a beacon of inspiration in the vast expanse of space. T-2b. In the vast expanse of the constellation Draco, some 750 light-years from Earth, lies a world shrouded in mystery and darkness. Known as Tres-2b, this exoplanet is one of the most enigmatic objects ever discovered. First detected in 2006 by the Transatlantic Exoplanet Survey, it holds the title of the darkest known planet, reflecting less than 1% of the light that falls upon it. This makes it darker than coal, darker than black paint, a true shadow in the starlit night. Tres-2b is a gas giant similar in size to Jupiter, but with a mass about 1.2 times greater. It orbits a sun-like star, T-2, at an incredibly close distance of just 0.036 astronomical units, completing a full orbit every 2.47 days. This proximity subjects the planet to intense stellar radiation, heating its atmosphere to a scorching 980°C. The planet is tidally locked, meaning one side always faces its star, basking in perpetual daylight, while the other side remains in eternal darkness. The planet's extreme darkness is a puzzle for scientists. Unlike other hot Jupiters, which reflect about 30-40 of incoming light, Tres-2b absorbs nearly all the light that reaches it. This could be due to an atmosphere rich in light-absorbing materials, such as vaporized sodium, potassium, or even exotic compounds like gaseous titanium oxide. The exact composition remains a mystery, but the planet's ability to swallow light makes it a fascinating subject for study. Tres-2b was discovered using the transit method, where astronomers observed tiny dips in the star's brightness as the planet passed in front of it. These observations not only confirmed the planet's existence, but also allowed scientists to measure its size and orbital period. Further studies using space telescopes like Kepler have provided more insights into its atmosphere and reflective properties. The planet's environment is as alien as it is extreme. Imagine a world where the sky is a perpetual twilight, with a star looming large on the horizon, casting a faint, eerie glow. The atmosphere, thick with gases, might glow faintly from the intense heat, creating a hellish landscape of swirling clouds and storms. TRES 2b is a reminder of the universe's capacity for extremes, a world where light itself seems to vanish. Studying TRES 2b offers a unique opportunity to understand the diversity of planetary atmospheres. Its extreme darkness challenges our models of atmospheric chemistry and heat distribution. At 750 light-years away, direct imaging is impossible, but future telescopes might one day reveal more about its composition. For now, TRES 2b remains a dark enigma, a planet that defies our expectations and invites us to explore the unknown. TRES 2b stands as a testament to the wonders of the cosmos. Its profound darkness and extreme conditions remind us that the universe is full of surprises, where worlds can exist in forms we can scarcely imagine. As we gaze into the night sky, this shadowy giant serves as a beacon of curiosity, urging us to continue our journey of discovery. WASP 12b. Imagine a world far beyond our solar system, nestled in the constellation Auriga, roughly 1,400 light-years away. This is WASP 12b, an exoplanet unlike any other, discovered in 2008 by the Wide-Angle Search for Planets project. It orbits its star so closely that a single year lasts just 1.09 days. This proximity bathes the planet in intense heat and subjects it to powerful gravitational forces, shaping it into a world both mesmerizing and tragic. WASP 12b belongs to a group of planets called hot Jupiters, gas giants that hug their stars tightly. It is about 1.4 times the mass of Jupiter, yet its radius is nearly double, puffed up by the relentless energy from its star. Temperatures on its surface climb to around 2,500 C, a heat so fierce it turns metals into vapor. The star's gravity has warped WASP 12b into an egg-like shape, with one side forever facing the searing light, locked in a perpetual day, while the other lingers in shadow. This extreme closeness leads to an astonishing sight. The planet's atmosphere is being torn away, pulled into a stream that trails behind it, like a comet's tail. Scientists estimate that WASP 12b loses mass so rapidly it may vanish into its star in just 10 million years, a fleeting moment in the vastness of time. This process of atmospheric escape paints a picture of a world unraveling before our eyes. The air around WASP 12b is a swirling mix of the strange and the exotic. Observations hint at vaporized metals like sodium and potassium drifting through its atmosphere, perhaps even traces of titanium oxide. It reflects almost no light, swallowing the star's rays and glowing with intense heat. This dark, scorching nature sets it apart, a planet defined by its struggle against the forces that surround it. Astronomers first spotted WASP 12b using the transit method, watching for the faint dimming of its star as the planet crossed in front of it. Later studies with telescopes like Hubble and Spitzer peeled back layers of its atmosphere, revealing its secrets. The planet's orbit is slowly tightening, drawing it ever closer to its star, a slow spiral toward its end. WASP 12b offers a window into the wild possibilities of distant worlds. Its distorted form and evaporating skies push the boundaries of what we believe planets can endure. Though it lies too far for us to see directly, it whispers clues about the universe's most extreme corners. Each discovery about this fleeting world deepens our awe of the cosmos. This planet's tale is one of impermanence and wonder. It reveals how stars and planets can lock into dances of creation and destruction. WASP-12b stands as a fleeting marvel, a reminder of the endless variety among the stars, urging us to keep exploring the mysteries they hold. In the constellation of Leo, some 124 light-years from Earth, lies a world that has captured the imagination of scientists and dreamers alike. Known as K2-18b, this exoplanet was discovered in 2015 by NASA's Kepler Space Telescope during its extended K2 mission. What sets it apart is its position in the habitable zone of its star, where conditions might allow liquid water to exist. This super-Earth, with its potential for oceans and an atmosphere rich with water vapor, offers a tantalizing glimpse into the possibility of life beyond our planet. K2-18b orbits a red dwarf star, K2-18, which is smaller and cooler than our Sun, completing an orbit every 33 days. The planet sits at just the right distance to receive a gentle warmth, potentially suitable for liquid water. With a radius about 2.3 times that of Earth and a mass roughly 8.6 times greater, K2-18b is classified as a super-Earth, likely with a rocky core surrounded by a thick atmosphere, or perhaps even oceans. Its surface gravity would feel heavier than Earth's, creating an alien experience for any imagined visitor. The planet's true allure lies in its atmosphere. In 2019, observations from the Hubble Space Telescope revealed water vapor in K2-18b's atmosphere, a groundbreaking discovery. Further studies with the James Webb Space Telescope have detected not only water, but also methane and carbon dioxide, hinting at a complex atmospheric chemistry. Some scientists speculate it could be an ocean world, covered entirely in water, or a planet with a hydrogen-rich atmosphere layered over rocky terrain. Intriguingly, traces of dimethyl sulfide, a molecule associated with life on Earth, have sparked debates about potential biosignatures, though these findings remain unconfirmed. K2-18b was identified using the transit method, where astronomers measured the slight dimming of its star's light as the planet passed in front of it. These observations allowed scientists to estimate its size and orbit, while spectroscopy revealed the composition of its atmosphere. The planet's density suggests it isn't a gas giant, but rather a world with a substantial rocky component, possibly cloaked in a deep atmosphere or liquid water. Its position in the habitable zone makes it a prime target for studying worlds that might resemble Earth in their potential for life. Exploring K2-18b pushes the boundaries of our technology. At 124 light-years away, direct imaging of its surface is impossible with current telescopes. Questions linger about its true nature. Is it a water world with vast oceans stretching across its surface? Does its atmosphere hold the right balance of gases to support life? Red dwarf stars like K2-18 can emit flares that might strip away atmospheres, but K2-18b's size and mass suggest it has held onto its protective envelope. Future observations, perhaps with advanced telescopes, could reveal more about its potential habitability. K2-18b stands as a beacon of possibility in the cosmos. Its water-rich atmosphere and place in the habitable zone challenge us to rethink what makes a planet suitable for life. As one of the most promising candidates for further study, it invites scientists to probe deeper into its mysteries, seeking clues to the conditions that might foster life elsewhere. This distant world, bathed in the faint glow of its red star, embodies the universe's capacity to surprise and inspire. Tucked away in the constellation Cetus, just 41 light-years from Earth, lies a world that has captured the attention of astronomers seeking signs of life beyond our planet. Known as LS1140b, this exoplanet was discovered in 2017 by the MERTH South Telescope Array, a project dedicated to finding planets around nearby stars. What makes this world remarkable is its position in the habitable zone of its star, where temperatures might allow liquid water to pool on its surface. As a rocky super-Earth, LS 1140b stands as one of the most promising candidates for habitability yet discovered. LS 1140b orbits a small, cool red dwarf star called LS 1140, which is only about 1/5 the mass of our Sun, completing an orbit every 24.7 days. The planet resides at a distance that places it squarely in the habitable zone, where conditions could support liquid water, a key ingredient for life as we know it. With a radius 1.7 times that of Earth and a mass approximately 6.9 times greater, LS 1140b is denser than our planet, suggesting a rocky composition with a possible iron-rich core. Its high density indicates it is not a gas giant, but a solid world, potentially with mountains, valleys, or even oceans. The planet's proximity to its star makes it tidally locked, meaning one side always faces the star in constant daylight, while the other remains in perpetual darkness. This creates a stark contrast between a scorching day side and a frigid night side, though a thick atmosphere could distribute heat and moderate these extremes. Observations suggest LS 1140b might retain a substantial atmosphere, possibly rich in water vapor or other gases, which could protect its surface and support liquid water. Unlike many planets around red dwarfs, LS 1140b orbits a relatively quiet star, with fewer flares to strip away its atmosphere, enhancing its potential for habitability. Astronomers detected LS 1140b using the transit method, observing tiny dips in the star's light as the planet passed in front of it. These measurements revealed its size and orbit, while follow-up observations with ground-based telescopes and the Spitzer Space Telescope helped determine its mass and density. The planet's high density suggests a rocky structure, possibly with a thin atmosphere or even surface water, though we lack direct evidence of these features. Its relatively close distance of 41 light-years makes it an ideal target for future studies, especially with telescopes like the James Webb Space Telescope, which could probe its atmosphere for signs of water or biomarkers. The study of LS 1140b pushes the boundaries of our search for life. Its rocky nature and habitable zone location make it a prime candidate for hosting conditions suitable for life, but challenges remain. Could its atmosphere support stable oceans? Does its tidally locked state allow for habitable regions, perhaps in the twilight zone between day and night? These questions drive astronomers to refine their models and observations, hoping to uncover the secrets of this nearby world. LS 1140b's proximity to Earth offers a rare opportunity to study a potentially habitable planet in detail, bringing us closer to answering whether we are alone in the universe. LS 1140b stands as a beacon of hope in the cosmic landscape. Its rocky surface and potential for liquid water challenge us to imagine worlds where life might thrive under alien skies. As one of the closest and most promising exoplanet for habitability, it inspires continued exploration, pushing the limits of our technology and curiosity. This small world orbiting a faint red star reminds us of the universe's vast potential to harbor life. In the constellation Crux, some 336 light-years from Earth, lies a world that challenges our understanding of how planets form and survive. Known as HD 106906b, this exoplanet was discovered in 2013 using direct imaging with the Magellan telescopes in Chile. What makes it extraordinary is its vast distance from its host star, orbiting at a staggering 650 astronomical units, about 20 times farther than Neptune is from our Sun. This massive, youthful gas giant stands as a cosmic outlier, a planet that seems to defy the rules of planetary systems. HD 106906b orbits a young, Sun-like star, HD 106906, which is part of a binary system and only about 15 million years old. The planet itself is a behemoth, with a mass estimated at 11 times that of Jupiter, making it one of the most massive exoplanets directly imaged. Its size is comparable to Jupiter, but its youth and distance from its star suggest it glows faintly with residual heat from its formation, casting a dim reddish light. With a surface temperature around 1500 C, it is far too hot for life as we know it, yet its isolation in the outer reaches of its system makes it a fascinating subject. The planet's orbit is its most puzzling feature. At 650 astronomical units, it takes roughly 13,000 years to complete a single orbit around its star. This distance raises questions about how HD 106906b formed. Traditional planet formation models suggest planets coalesce close to their stars within a protoplanetary disk, but this world lies far beyond where such disks typically extend. Some scientists propose it formed closer to its star and was later flung outward by gravitational interactions, possibly with the binary companion star or another unseen body. Alternatively, it might have formed like a star, condensing directly from a cloud of gas and dust, blurring the line between planet and brown dwarf. HD 106906b was captured through direct imaging, a rare feat that allowed astronomers to see its faint glow against the backdrop of space. This technique, combined with observations from the Hubble Space Telescope, revealed a debris disk around the star, a ring of dust and gas that might hint at the system's chaotic past. Intriguingly, the disk appears misaligned with the planet's orbit, suggesting a turbulent history of gravitational tugs and pulls. This misalignment adds to the mystery, hinting at unseen forces that shaped this distant world. Studying HD 106906b pushes the boundaries of planetary science. Its extreme orbit challenges models of how planets are born and evolve, while its massive size and youthful glow offer clues about the early stages of planetary systems. At 336 light-years, it is close enough for detailed observations, and future telescopes like the James Webb Space Telescope could reveal more about its atmosphere, potentially rich in methane or other gases. The planet's isolation also raises the possibility of unseen moons or rings, though none have been detected yet. HD 106906b stands as a cosmic enigma, a massive world adrift in the outer reaches of its system. Its lonely orbit and mysterious origins invite us to rethink the possibilities of planetary formation. As a testament to the universe's complexity, this distant giant inspires astronomers to probe deeper into the forces that shape worlds across the stars. WASP 17b. In the constellation Scorpius, approximately 1,000 light-years from Earth, orbits a planet that defies expectations with its peculiar characteristics. Known as WASP 17b, this exoplanet was discovered in 2009 by the Wide-Angle Search for Planets WASP project. It stands out as one of the largest and least dense exoplanet ever found, with a size nearly twice that of Jupiter, but only half its mass. Even more intriguing, it travels in a retrograde orbit, moving opposite to its star's rotation, a cosmic anomaly that challenges our understanding of planetary formation. WASP 17b is a hot Jupiter, a class of gas giants that orbit extremely close to their stars. It circles its sun-like star, WASP 17, every 3.7 days at a distance of just 0.051 astronomical units. This proximity heats the planet's atmosphere to a blistering 1700 C, causing it to expand dramatically. With a radius about 1.9 times that of Jupiter, WASP 17b is extraordinarily puffed up, earning it the nickname of a puffy planet. Its low density, comparable to styrofoam, suggests a composition dominated by hydrogen and helium, with a possible rocky or metallic core buried deep within. The planet's retrograde orbit is its most striking feature. Unlike most planets, which orbit in the same direction as their stars spin, WASP-17b moves in the opposite direction. This backward motion suggests a turbulent history, possibly involving gravitational interactions with another planet or star that reversed its orbit. Such events are rare and provide clues about the chaotic early days of planetary systems. The discovery of this orbit, confirmed through precise measurements of the star's light and the planet's gravitational effects, marked WASP-17b as a unique case in exoplanet research. Astronomers detected WASP-17b using the transit method, observing the slight dimming of its star's light as the planet passed in front of it. These observations revealed its enormous size and short orbital period. Further studies with telescopes like Hubble and Spitzer have probed its atmosphere, detecting traces of water vapor and sodium, hinting at a complex chemistry driven by intense stellar radiation. The planet's bloated atmosphere likely results from the extreme heat, which causes gases to expand, making it one of the largest known exoplanet. Studying WASP-17b offers insights into the extremes of planetary systems. Its low density and retrograde orbit challenge models of how gas giants form and migrate. At 1,000 light-years away, direct imaging remains beyond our reach, but future telescopes like the James Webb Space Telescope could reveal more about its atmospheric composition, potentially uncovering exotic compounds or cloud structures. The planet's size and orbit make it a prime target for understanding the dynamics of hot Jupiters and their interactions with host stars. WASP-17b stands as a testament to the universe's diversity. Its massive, fluffy structure and backward orbit paint a picture of a world shaped by extraordinary forces. As astronomers continue to study this puffy giant, it pushes the boundaries of our knowledge, revealing the complex histories of planets far from home. This strange world in Scorpius serves as a reminder of the endless possibilities among the stars. Kelt 9b. In the constellation Cygnus, roughly 650 light-years from Earth, orbits a planet that pushes the boundaries of what we believe planets can endure. Known as Kelt 9b, this exoplanet was discovered in 2017 by the kilodegree Extremely Little Telescope Kelt survey. It holds the record as the hottest known exoplanet, with temperatures soaring to an astonishing 4,300 C on its day side, hotter than the surfaces of many stars. This ultra-hot Jupiter is a world of extremes, bathed in relentless stellar radiation that creates a truly alien environment. Kelt 9b is a massive gas giant, about 2.8 times the mass of Jupiter and nearly twice its diameter. It orbits a scorching hot Blua-type star, Kelt 9, which is almost twice as massive and significantly hotter than our Sun. The planet completes an orbit every 1.48 days at a mere 0.035 astronomical units from its star, making it one of the closest known exoplanet orbits. This proximity causes the planet to be tidally locked, with one side perpetually facing the star's intense light, while the other remains in shadow, creating a stark contrast between a blazing day side and a cooler, yet still extreme, night side. The planet's blistering temperature is its defining feature. At 4,300 C, the day side is so hot that molecules like water, methane, and even hydrogen struggle to remain intact, dissociating into their atomic components. This gives Kelt 9b an atmosphere unlike any in our solar system, potentially filled with vaporized metals and atomic hydrogen. Observations suggest the planet's atmosphere is inflated by the intense heat, making it appear larger than typical gas giants. Some studies even propose that the star's radiation is stripping away the planet's atmosphere, creating a comet-like tail of escaping gas. Astronomers detected Kelt 9b using the transit method, observing the star's light dim slightly as the planet passed in front of it. Follow-up observations with telescopes like Hubble and Spitzer revealed details about its atmosphere, detecting signs of iron and titanium atoms, a rare find in exoplanet atmospheres. These metals, vaporized by the extreme heat, hint at a chemistry more akin to a star than a planet. The planet's orbit is also slightly tilted, adding complexity to its interaction with the star's intense radiation and magnetic fields. Studying Kelt 9b offers a unique window into the extremes of planetary systems. Its scorching environment and exotic atmospheric chemistry challenge our models of how gas giants behave under intense stellar radiation. At 650 light-years, direct imaging of its surface is beyond current technology, but instruments like the James Webb Space Telescope could reveal more about its atmospheric dynamics and mass loss. The planet's extreme conditions make it a natural laboratory for understanding the limits of planetary survival. Kelt 9b stands as a testament to the universe's capacity for extremes. Its fiery atmosphere and tight orbit around a blazing star paint a picture of a world pushed to the edge of existence. As astronomers probe its mysteries, this ultra-hot Jupiter reveals the diverse and dynamic nature of planets across the cosmos, inspiring us to explore the boundaries of what worlds can be. Proxima Centauri b. In the constellation Centaurus, just 4.24 light-years from Earth, lies the nearest known exoplanet to our solar system. Known as Proxima Centauri b, this world was discovered in 2016 by the Pale Red Dot campaign using the European Southern Observatory's telescopes. Orbiting the closest star to our Sun, Proxima Centauri, this planet resides in the habitable zone, where conditions might allow liquid water to exist. Its proximity and potential for habitability make it one of the most tantalizing worlds ever found, a beacon of possibility in our cosmic neighborhood. Proxima Centauri b orbits a red dwarf star, Proxima Centauri, a faint, cool star only about 1/8 the mass of our Sun, completing an orbit every 11.2 days at a distance of 0.049 astronomical units. The planet sits much closer to its star than Earth does to the Sun. Yet the star's low luminosity places it in the habitable zone. With a minimum mass roughly 1.17 times that of Earth, it is likely a rocky super-Earth, possibly with a solid surface of rock or ice. Its size remains uncertain, but estimates suggest a radius slightly larger than Earth's, hinting at a world with familiar yet alien terrain. The planet's environment is shaped by its star's nature. Proxima Centauri is an active red dwarf, prone to powerful flares that release intense bursts of ultraviolet and X-ray radiation. These flares could challenge the planet's ability to retain an atmosphere, a critical factor for habitability. However, its relatively high mass suggests it might hold onto a thick atmosphere, potentially rich in water vapor, nitrogen, or carbon dioxide. Being tidally locked, one side of Proxima Centauri b faces constant daylight, while the other is in perpetual darkness, creating extreme temperature contrasts unless an atmosphere redistributes heat. Astronomers discovered Proxima Centauri b using the radial velocity method, detecting tiny wobbles in the star's motion caused by the planet's gravitational pull. This technique revealed its mass and orbit, but left many questions unanswered. Does it have oceans or a protective magnetic field? Could microbial life thrive in its twilight zone, where day meets night? Observations with telescopes like ALMA and Hubble have begun to probe its system, but direct evidence of an atmosphere or surface conditions remains elusive. Its closeness makes it a prime target for future missions, including potential space probes like Breakthrough Starshot. Studying Proxima Centauri b pushes the limits of our technology and imagination. At just 4.24 light-years away, it is the closest exoplanet we can study, yet its faint star and small size make detailed observations difficult. Future telescopes, such as the James Webb Space Telescope or the Extremely Large Telescope, could analyze its atmosphere for signs of water, oxygen, or even biosignatures. The planet's survival in the face of stellar flares offers clues about how habitable worlds form around red dwarfs, the most common stars in the galaxy. Proxima Centauri b stands as a landmark in our search for life beyond Earth. Its place in the habitable zone and proximity to our solar system make it a symbol of hope and curiosity. As the closest known exoplanet, it challenges scientists to refine their tools and theories, pushing us closer to understanding whether life exists elsewhere. This nearby world, orbiting a faint red star, embodies the universe's potential to harbor new frontiers. Kepler 452b. Nestled in the constellation Cygnus, approximately 1,800 light-years from Earth, lies a world that feels like a distant echo of our own. Known as Kepler 452b, this exoplanet was discovered in 2015 by NASA's Kepler Space Telescope. Often dubbed Earth's cousin, it is one of the most Earth-like planets found in the habitable zone of a Sun-like star, where conditions might allow liquid water to exist. Its discovery sparked wonder, offering a glimpse of a world that could resemble our own in size, orbit, and potential for life. Kepler 452b orbits a star called Kepler 452, a G-type star remarkably similar to our Sun, but slightly older, at about 6 billion years. The planet completes an orbit every 385 days, a year strikingly close to Earth's, at a distance of 1.05 astronomical units. This places it in the habitable zone, where temperatures could support liquid water on a rocky surface. With a radius about 1.6 times that of Earth, Kepler 452b is classified as a super-Earth, likely with a rocky composition, though its mass remains uncertain, estimated between 5 to 10 Earth masses. Its size and orbit suggest a world with potential for continents, oceans, or even an atmosphere capable of sustaining life. The planet's star, being older than our Sun, offers a glimpse into what Earth's future might hold as our own star ages. Kepler 452b's position in the habitable zone implies it could have experienced stable conditions for billions of years, potentially allowing complex life to evolve if the right ingredients are present. However, its exact nature remains a mystery. It might be a rocky world with vast landscapes or a mini Neptune with a thick gaseous envelope. Without direct measurements of its mass or atmosphere, scientists rely on models to infer its composition, leaning toward a rocky planet due to its size and orbital characteristics. Astronomers detected Kepler 452b using the transit method, observing tiny dips in the star's light as the planet passed in front of it. These observations confirmed its size and orbit, but its distance of 1,800 light-years makes detailed follow-up challenging. The planet's star is slightly brighter and hotter than our Sun, which could push Kepler 452b toward a greenhouse effect if it has a thick atmosphere, potentially warming its surface beyond Earth-like conditions. Future telescopes, such as the James Webb Space Telescope, might one day probe its atmosphere for signs of water vapor, oxygen, or other gases that could hint at habitability. Studying Kepler 452b stretches our understanding of habitable worlds. Its Earth-like orbit and Sun-like star make it a compelling target for exploring the conditions needed for life, but its distance limits our ability to study it closely. Questions abound about its surface, atmosphere, and history. Could it host oceans or ecosystems? Has its aging star altered its climate over billions of years? These uncertainties drive astronomers to refine their techniques, hoping to uncover more about this distant world and others like it. Kepler 452b stands as a symbol of cosmic kinship. Its Earth-like traits and long, stable history in the habitable zone inspire us to imagine worlds where life might flourish. As a bridge between our planet and the unknown, it challenges scientists to push the boundaries of exploration, revealing the diversity of worlds orbiting stars across the galaxy. This distant cousin in Cygnus remains a beacon of possibility in the vast expanse of space. Kepler 22b. In the vast expanse of the constellation Cygnus, some 600 light-years from Earth, lies a star that could easily be mistaken for our own Sun. Orbiting this star is Kepler 22b, a planet that has captivated astronomers and dreamers alike since its discovery in 2011 by NASA's Kepler Space Telescope. It was the first confirmed exoplanet found in the habitable zone of a Sun-like star, a region often called the Goldilocks zone, where conditions might be just right for liquid water and potentially life to exist. This distant world offers a glimpse into the possibility of Earth-like planets scattered across the galaxy. Kepler 22b orbits its host star, Kepler 22, a G-type star nearly identical to our Sun in mass and temperature. The planet completes its orbit every 290 days, at a distance of about 0.85 astronomical units, slightly closer than Earth is to the Sun. Despite this, it receives approximately 25% more stellar energy than Earth, placing it comfortably within the habitable zone. With a radius about 2.4 times that of Earth, Kepler 22b is classified as a super-Earth, a planet larger than ours, but smaller than gas giants like Neptune. Its mass remains uncertain, estimated to be less than 36 Earth masses, leaving open the question of whether it is a rocky world, a water-rich ocean planet, or something entirely different. The planet's size and location make it a tantalizing candidate for habitability, but much about Kepler 22b remains shrouded in mystery. Its composition is unknown. It could be a rocky planet with a solid surface, a water world enveloped in deep oceans, or even a mini Neptune with a thick gaseous atmosphere. If it has an atmosphere similar to Earth's, the increased stellar flux might create a temperate climate, potentially allowing liquid water to flow across its surface. However, if its atmosphere is thicker, it could trap heat like Venus, rendering the planet too hot for life. Without precise measurements of its mass or atmospheric properties, scientists can only speculate about its true nature. Kepler 22b was discovered using the transit method, where astronomers observed tiny dips in the star's brightness as the planet passed in front of it. These observations confirmed its size and orbit, but the planet's distance of 600 light-years makes detailed follow-up observations challenging. Future telescopes, such as the James Webb Space Telescope or the upcoming Plato mission, might one day analyze its atmosphere for signs of water vapor, oxygen, or other biosignatures. For now, Kepler 22b remains a world of possibilities, a blank canvas onto which we project our hopes for finding life beyond our solar system. Studying Kepler 22b stretches the limits of our current technology. Its faint star and small size relative to gas giants make it difficult to observe directly, yet its position in the habitable zone keeps it at the forefront of exoplanet research. Questions about its surface, climate, and potential for life drive astronomers to refine their methods and develop new tools. Could it host oceans teeming with life, or is it a barren, inhospitable world? These uncertainties remind us of how much we have yet to learn about the universe and the diversity of planets it holds. Kepler 22b stands as a milestone in our search for habitable worlds. Its Earth-like orbit around a Sun-like star offers a vision of what could be, a planet where life might thrive under a familiar sky. As one of the first confirmed planets in the habitable zone, it symbolizes the beginning of a new era in astronomy, where we can begin to answer age-old questions about our place in the cosmos. This distant world in Cygnus serves as a reminder of the endless possibilities that await discovery among the stars.